Hi, this is Brian Fogarty, and this is a video for Chapter 13 of the book Quantitative Social Science Data with R, second edition. So in this video, what we're going to do is look at ordered logit models in R. So in the previous handful of videos, we looked at binary, logit, and probit, so sort of binary outcome models. Now we're looking at ordered outcome models. Ordered outcome models are very similar to binary. I mean, we could think actually of the binary as a special case of ordered. So we use ordered outcome models when our outcome variable is an ordinal level variable. So these are very common in social science to have ordinal outcome variables. Especially if you work with survey data, so many different types that you might have here. Just think about the disagree, agree, disagree questions, right? Those are ordered. So in this video, again, we're just going to look at ordered logit. Next video, we're going to look at ordered probit. Okay, so we are still using the Scottish social attitudes data. Okay, so it's not perfect for it, but it's a good way to just continue sort of with the same data set that we're using in the binary. All right, so we are going to use a function for ordered logit that is polr. The PO or polr, I guess, polr function, and this stands for proportional odds logistic regression. That is one of the other names for ordered logit, and even though logistic is in the name, we can also run probit with it. So this function is from the mass library. All right, so we need to load that, even though it's part of, I think it is, that it's like it's not base R per se, but it's downloaded. We see here though that this package overwrites or masks the select function from dplyr, and that's something that when we're working with data, a lot of times we do use that. So if we need that, we might need to detach mass to get it back. All right, so we are going to use the same set of variables that we did, except we're going to move it around a little, and we are going to use trust in the British government as our outcome variable. We have to do one thing, and we could actually do this within the regression, but let's just be more specific and clear about it. What we need to do is we need to create an ordered factor version of the trust variable. Okay, so we are going to just create a new variable for that. So I'm going to do, so SSA is our data. I'm going to do SSA, and then we're going to use the mutate function, and I'm going to call this trust underscore ord fac. Very original. It's kind of an annoying name actually. I don't know if I love it, but it's clear. Well, maybe it's clear. That's trust ordered factor. Okay, so we're going to use ordered, the ordered function, which we saw in the previous video when we were doing the predicted probability plot. So ordered, and then as underscore factor, and then trust. Okay, so this will create an ordered factor, and we need this in order to run the ordered logit with the polr function. I don't even know it's polr, whatever. That's what I'm going to go with. I'm going to go with polr. All right, so otherwise everything else looks pretty much the same as we've seen before with binary, logit, probit, and linear regression. So we're going to use summary. We're going to wrap summary around so we get the results spit out. I'm going to save the results as model.ologit. And then the function is polr, as I've been saying, polr, and then truss ord fac tilde, and then ref vote plus Scott plus age. Okay, so with the binary outcome, we had Scott and age as predictors, and we had ref vote as the outcome variable. Now we're using it as a predictor. I know it's very ingenious. All right, and then we're going to specify method, even though I think the default is Logit, but we'll specify method equals logistic. Okay, it's a little bit different. And then data equals SSA. Okay, so let's highlight that and run that. Don't worry about this information here that says refitting to get Hessian. It's just how it's estimated. All right, so here are the results. And you might say, where are my stars? Where are my p-values? They are not here. But again, if you remember from our discussion, for binary logit and probit and linear regression, the output gave us redundant information. So what we really need to do is just look at the t-value. And so we're looking for roughly an absolute value of roughly 2. It's just going to depend on the size, the number of observations we have, but let's say roughly 2. So if it's greater than that, the absolute value, then it's statistically significant. So looking at this, we see the t-value for ref vote and Scott are statistically significant, because even though it's negative, it doesn't matter. All right, it's only negative because the t-value is this thing that says value, which is our coefficient or estimate, divided by the standard error. So it's only negative because the regression coefficient is negative. All right, and then age is not. Okay, so the ref vote, we saw this before with this. So the ref vote is a dummy variable, and by default, what R does is that it gives us the name of the variable. Why is this not letting me highlight? There we go. It gives us the name, and it also gives us here the higher category, which is vote yes, or a yes vote. All right, so this is the effect of yes vote versus no vote for trust in the British government. So it's negative. So what that implies is that people that plan to vote yes for Scottish independence have lower trust in the British government than people that plan to vote no, which is as expected. Scott is also negative. That means as the strength of Scottish identity increases, people have lower trust in the British government. That is also as expected. Okay, we see down here, I didn't reverse the order, which I usually do, but the AIC is model fit on its own. It's not very useful. We use it to compare different models. Okay, so just like with Logit and probit binary, we cannot directly interpret it. We'll look at odds ratio and predicted probabilities for interpreting these. But that's it for this video. We're just taking a quick look at how to run this in R. All right, so thanks for watching, and I'll see you next time.